Good morning, students. Welcome to the video class on three-dimensional geometry. Today we will discuss about basic concepts of three-dimensional geometry like direction ratios, direction cosines, relation between them, okay, and the relation between direction, cosines and line. Okay, that and all we will discuss now. Three-dimensional geometry. See, children, if you look at three-dimensional geometry, some students, not all the one, some students they feel this is a difficult chapter, okay. But actually, it is not very difficult, okay. But when it is difficult, when it is easy, we'll discuss some issues like imagination. In some, if you are having these skills, then it is very easy. One is imagination. So, what is meant by this imagination? Actually, three-dimensional means sometimes we have to imagine in the figure and all, right? Why? Because this is three-dimensional, x-axis, y-axis and z-axis, right? So, like you, some objects, you know that cube, cuboid, cylinder, these are all three-dimensional figures, right? So, some imagination is needed sometimes. Then alone we can understand this concept very well. Then vector algebra. You have some knowledge about, full knowledge about vector algebra. So, vector already we discussed vector algebra, it is easy. The same application we are using in three-dimensional geometry also. The concepts of vector algebra, direction, cosines, direction ratios, that and all. And then DRs and DCs. What is meant by DRs? DRs means direction ratios. And DCs. DCs of a line or vector. Okay. DCs of a line or vector. Next one, relation between DRs and DCs. Next, relation between DRs and DCs. So, while we are studying this about, so we should have some knowledge about this one, children, that is geometry. Okay, geometrical understanding. This is the skill is very important. Geometrical understanding. Okay. See, you must have some imagination skill. Sometimes you have to imagine the thing, and okay, with respect to the given data, you have to understand the question or concept. Let us imagine some figure and all, and you must have knowledge about vector algebra. Okay, this DRs, what is meant by DRs and DCs of a line, that you must have some knowledge about this one, and relation between them, and geometrical understanding, geometrical understanding, right? So that is one more thing. And then next one, lack of regularity. Suppose connectivity, if you are, okay, lack of regularity. So see here, suppose if you are today we are doing about DRs and DCs, okay, you are tomorrow and relation between DRs and DCs, okay, then if you are missing this one DRs and DCs, today's class if you are missing now, tomorrow the relation between what is the connecting topic DRs and DCs you may not understand. That's a lack of regularity. So if you are regularly, if you attend this one class or practice, okay, lack of regularity, nothing but practice, lack of practice also, that also you can write, proper practice. Last one, proper practice. Even proper practice not there also, then you can't understand this chapter. Okay, children, do you understand, children? See, these are the things, some important points. Okay, imagination, sometimes you have to imagine what is diagram, like, okay, what is the relation between plane and line, okay, like that, okay, what is the angle between plane and line, how it will be, okay, that and all, what is meant by DRs, what is meant by DCs, what is the relation between them, what is the geometrical figure, okay, will you draw the geometrical, maximum will try, okay, but at least you can imagine the thing according to the given data. And lack of regularity, you are missing some concepts in between them, okay, okay, then also you can't understand this one. Suppose if you regularly, if you attend the class or regularly if you practice now, then it is easy chapter. Proper practice. If proper practice not there also, you will come down in this three-dimensional geometry. But if you try to understand the concept, it is very easy topic compared to other topics. Okay, around 30 plus concepts are there in chapter. 30 plus concepts are there, but formula based, purely formula based. Okay, but thing is, if follow these points now, then it is very easy, easy scoring, right? Around 10 mark from this chapter alone. Okay, 10 mark. Okay, according to the new pattern, maybe plus or minus 10. Okay, that is there. Okay, children. So now we'll come back to this one topic. Okay, right, children. Right, first of all, what is mean by DRs? Okay, DRs nothing but direction ratios. Okay, direction ratios. Direction ratios. So, what is mean by this direction ratios? This is in short form DRs. DRs. So, direction ratios nothing but three number. Just three number. Okay, that are you right. Any three number definition. Any three numbers which are proportional to. Any three number proportional to the direction cosines. Proportional to the direction cosines. Okay. Direction. What is meant by that? Also see. Direction cosines of a line are called. Of a line are called. Of a line are called direction ratios. DRs. Direction ratios. Do you understand, children? See, direction ratios. Yes, children. Now see. Okay, here according to see three-dimensional means you know that the point in the form of x, y, z. Two-dimensional means x comma y. Okay, that there we are using only plane surface. Here we are using space. That is the difference between two-dimensional and three-dimensional. In two-dimensional there exists length and breadth alone. Okay, but in three-dimensional length, breadth, height also. There are three-dimensional figures. You know very well, right? Right. Here normally, okay, A, if you take one point, this is in the form of triplet. Okay, x1, y1, z1. Order pair is triplet. There is doublet. Okay, x comma y. But here triplet. Okay, and B you take x2, y2, z2. So it is very simple. The direction ratios, how to evaluate direction ratios using these 2 points A comma B. Okay, DRs of AB, direction ratios. This is x1, y1, z1. This is x2, y2, z2. DRs of AB vector. Okay, AB. It is what, children? X2 minus x1, y2 minus y1, z2 minus z1. These are the direction ratios. In other form, in other way, we can write A, B, C also. Okay, if vector R bar or AB bar is equal to AI plus BJ plus CK. Here DRs are what? DRs are A comma B comma C. DRs are A comma B comma C. Do you understand, children? Difference of, okay, final position minus initial position, x2 minus x1, y2 minus y1, z2 minus z1. Or suppose directly if they give AI plus bj plus ck means vector notation means a comma b comma c are the direction ratios. Direction ratios is nothing but just simple three number which are proportional to the direction cosine. Then what is mean by direction cosines? That we will discuss now. Okay, Do you understand, children? These are just three numbers which are proportional to the direction cosines. If 2 points are given, x2 minus x1, y2 minus y1, z2 minus. Someone asked me the question, sir, I will take x1 minus x2, y1 minus y2, z1 minus z2. Yes, you can take, no issue. Why? Because proportional, just which are proportional to the direction cosines. Okay, proportional value you can take, no problem. Okay, that's why either x1 minus x2, normally usually we can proceed from, okay, according to the concept of vector algebra, AB is equal to, you know very well, AB bar is equal to OB bar minus OA bar. Okay, why? Because it is vector. Vector is what? A directed line. It is a directed line. We can consider direction also. That is the reason usually we are writing x2 minus x1, y2 minus y1, z2 minus z1. Even x1 minus x2, y1 minus y2, z1 minus z2. Sir, why sir difference? What is the difference in that? Only difference, that is proportional values, that's all. Anyhow, direction ratios are scalars, okay, scalar quantity. So we can take no issue, okay. Usually this is the formula, x2 minus x1, y2 minus y1 and z2 minus z1. Do you understand, children, how to find direction ratios? If direct of vector is given, then how to find ijk coefficient? What is meant by ijk? That already you know that unit vector along x-axis, y-axis and z-axis. X-axis and y-axis and z-axis. Okay, that are unit vectors along ox, oy and oz. That's why if you are really strong in vector algebra, three-dimensional geometry is easy for you. But you follow what I give instructions. Sometimes you have to imagination and you have to regularly have to practice, and you must have knowledge about vector algebra and proper practice. Okay, lack of practice. Okay, lack of understanding some scale, some geometrical figures and diagrams. Then also you can come down in this area. Okay, but it is not very tough. My opinion, even 3D we can enjoy the subject. Okay, right, children. Next one, we'll move on to direction cosines. What is meant by direction cosines? Next concept, direction cosines. First of all, write down the definition. What is meant by direction cosines? These are direction cosines. Or definition you write, if any line makes alpha, beta, gamma, makes alpha, beta, gamma with positive axis, with positive direction of x, y, z axis, positive direction of x, y and z axis, x, y and z axis, then cos alpha, cos beta, cos gamma are called DCs of a line. What is meant by DCs, children? So suppose you take just here, you take three axes, x, y, z, x, okay, this is y and this is z. Here you take one vector OP bar. This one it makes alpha with x-axis, beta with y-axis and gamma with z-axis. Okay, here this is, you take something like A and put a perpendicular AB. Okay, children, okay, and this is z-axis. Now see, this what is meant by alpha, beta, gamma. These are the directed angles. Okay, directed angles. The cosines of directed angles are nothing but what? Direction cosines. Okay, cosines of directed angle made with x-axis, y-axis and z-axis are called direction cosines. In other words, we can use LMN also. LMN also. That is why you write down the, okay, here if L, M, N are if L comma M comma N, okay, are DCs of a line, DCs of a line. Then what is the relation between them? L square plus M square plus N square is equal to 1. This is an important note. This in other words we can also can be written as cos square alpha plus cos square beta plus cos square gamma is equal to 1. Do you understand, children? So this is about direction cosine. See here OP is a vector. Make alpha angle with positive x-axis, beta with positive y-axis, gamma with positive z-axis. We combine with cosine, cos alpha, cos beta, cos gamma. Those are denoted as direction cosines. Do you understand, children? Right. This is the relation among them. Cos square alpha plus cos square beta plus cos square gamma, nothing but 1. Okay. Right, children. Now, relation, we will move on to relation between direction cosines, direction basis and direction cosines. Is there any relation between them? Next one. Next concept, relation next concept, relation or among or between, relation between DRs and DCs of a line, What is the relation between direction cosines, direction ratios and direction cosines? If LMN are DCs of a line, DCs and ABC are DRs of a line, then is there any relation between them? That is L by A, M by B, N by C is equal to lambda. As we discussed about this one, direction ratios of three numbers which are just proportional to the direction cosine. See, L by A proportional to lambda in the ratio of lambda, M by B, N by C. It implies what, children? This is a relation A lambda and M is equal to what, children? B lambda and N is equal to C lambda. See, now as we discussed about this one, A square, L square plus M square plus N square, what happened, children? But we know that L square plus M square plus N square is equal to 1. If you substitute here this value, what happens, children? A square lambda square, B square lambda square, C square lambda square, which is equal to 1. It implies A square plus B square plus C square into lambda square is equal to 1. So now we'll find the lambda square value, that is 1 by A square plus B square plus C square. It implies lambda is equal to plus minus 1 by square root of A square plus B square plus C square. Okay, children, this is the value of lambda. So now how to derive? If you know direction ratios, how to derive direction cosines? Suppose see, if A, B, C are DRs of a line, DRs, then DCs are, then direction cosines are plus minus, just you write, the direction cosines, L is equal to A lambda, lambda value is what? Plus minus square root of A square plus B square plus C square. So plus minus A by square root of A square plus B square plus C square, plus minus B by square root of A square plus B square plus C square, plus minus C by square root of A square plus B square plus C square. Do you understand, children? Once if you know the direction ratios A, B, C, then we can derive direction cosines using this concept. Why? Because how are you getting lambda value? See, L by A, direction ratios and direction cosines are in some proportional values of direction cosines, direction ratio. From here L by A is equal to lambda. L is equal to what? A lambda. Lambda is what? Plus minus 1 by square root of A square plus B square plus C square. Already L is equal to A by. So plus minus A by square root of A square plus B square plus C square. Okay, do you understand, children? Right. The next one. Suppose someone asks me the question, sir, suppose direction cosines are given, then how to find direction ratios? See, direction cosines, L is given, then A is equal to what, children? Obviously, A is equal to L by lambda, B is equal to M by lambda, C is equal to N by lambda. Then what about direction lambda value? Already you know that. Direction cosines, okay. Lambda, 1 by lambda, that is proportional value, okay. And L, M, N, right now, then nothing but their direction ratios using direction cosines. Do you understand, children? Very simple. Try to understand the concept. These are all interrelated. Okay, direction ratios, direction cosines, relation among direction cosines of a line. Okay, okay, children. Right. Next. Next one, next concept. So next concept, relation, okay, direction cosines of a line passing through 2 points. Next, direction cosines. This is of a line. This is of a line passing through passing through 2 points. Passing through 2 points. If 2 points are given, how to find direction cosines? Okay, here if L, M, N be the, if L, M, N, okay, be the direction cosines, this is of a line, this is of a line PQ, this is of a line PQ, and it makes alpha, beta, and it makes alpha, beta, gamma with, okay, alpha, gamma with x, y, z axis, x, y and z axis. Do you understand, children? Right. Then, okay, then okay, we'll write cos alpha nothing but x2 minus x1 by PQ, okay, and cos gamma, cos beta is equal to y2 minus y1 by PQ, y1 by, and cos gamma is equal to z2 minus z1 by PQ. Do you understand, children? L, M, N are direction cosines of line PQ. Here PQ in the sense what, children? Like this actually. Okay, okay. Magnitude of PQ. You know that how to find the distance between 2 points. That also right. How to find PQ? Suppose P is x1, y1, z1. Okay. x1, y1, z1 and Q is x2, y2, z2. Then ZPQ is equal to PQ. How to find magnitude? We studied in 11th 3D, 11th 3-dimensional geometry. x2 minus x1 whole square, y2 minus y1 whole square, and z2 minus z1 whole square. Okay, this already we studied. That's why we are not doing this one. Distance between 2 points, centroid, midpoint, section formula. Okay. And this and all we studied collinear points. If 2 points or 3 points are collinear, then how, like, okay, children, here in 12th standard, suppose if 3 points are collinear, last year in 11th standard what we use, we will find is, okay, AB magnitude, BC magnitude and AC magnitude, then we will add any two, okay, lengths and which is equal to third one, therefore collinear. But this year, collinear condition, see, what is the condition for collinearity? Okay. Suppose if 3 points are collinear, how to show that? If three are A, B, C are collinear, if A, B, C are collinear points, okay, how to show that collinear? Okay, using direction ratios. Okay, direction ratios. Not like last year, children. Here, how to show that A, B, C are collinear means if d of AB is equal to d of BC are also equal to d of AC. Do you understand, children? Okay. Then drs of AB is equal to drs of BC or drs of AC. Then these are collinear. Also this one we are using for parallel. So what is the difference between parallel condition or collinear condition? So here exactly equal, children. Parallel means suppose AB is parallel to some CD. Okay, these two are parallel. So here same proportion. Drs of AB same as drs of CD. Then parallel. Here equal. Here exactly equal. And here same proportion or in same proportion. Same proportion means parallel. Okay, two lines are parallel. Here collinear means lie on the same line. You know that. Okay. But till last year, this one how actually we will find AB distance and BC distance, then AC distance, then AB plus BC is equal to AC. That last year in 11th standard we studied that. But this year, drs, if you find drs, how to find drs of AB? Then using this condition. What is the condition? If you know 2 points, x2 minus x1, y2 minus y1, z2 minus z1 of AB. Similarly, you take BC, same formula apply, x2 minus x1, okay, or x3 minus x1, y3 minus y3 minus y2, z3 minus z2. These two direction ratios are equal, then ABC are collinear. That's all this year, okay. Right, using this condition, collinear condition, okay. Parallel means direction ratios of AB is equal direction ratios of BC. Then how to show that if two lines are perpendicular using direction ratios? Then we'll come back to that one. That is perpendicularity, condition of perpendicularity. That we'll discuss now. Condition right. If two conditions are, if two lines are perpendicular, then how to show that two lines are perpendicular? Using direction ratios, right? So if A1, B1, C1 and A2, B2, C2 are drs of okay, two lines L1, L2, two lines, okay, L1 and L2, then see, then there exists one condition, that is A1, A2, B1, B2, C1, C2 is equal to 0. It is very, very important, children. Okay, this is the condition if two lines are perpendicular. If you know direction ratios of two lines individually, then if this condition is satisfied, then it is perpendicular to one another. Sir, someone asked me the question, sir, I don't know direction ratios, but I have direction cosines. Is there any other condition, sir? Yes. Yes, you have another condition, okay, with respect to direction cosines. That also will write now. Okay, that is if, yes, if L1, M1, N1 and L2, M2, N2 are BCs of direction cosines of two lines L1 and L2, then there is a condition, that is okay, L1, L2, M1, M2, N1, N2. which is equal to 0. Okay, right children? This is the condition satisfied, then also two lines are perpendicular to one another. Okay, now we studied about if two lines are, okay, I mean 3 points are collineate, then what is the condition? Okay, direction ratios of AB is equal to direction ratios of BC or direction ratios of AC. If two lines are parallel, direction ratios of AB are proportional to direction ratios of CD, then also parallel. Okay, then perpendicular condition, if you know A1, B1, C1, A2, B2, C2 are direction ratios of two given lines, then A1, A2 plus B1, B2 plus C1, C2 is equal to 0, that is perpendicular condition. If L1, M1, N1, L2, M2, N2 are given direction cosines of given lines, then is there any condition L1, L2 plus M1, M2 plus N1, N2? Now someone asked me the question, sir, if okay, neither parallel nor perpendicular, there exists one another case, that is intersecting case. Then how to find the angle between two lines if you know direction ratios? That we'll discuss now. Okay, that is, okay, if A1, B1, C1 and A2, B2, C2 are DRs of given lines, two lines, okay, two lines L1 and L2. These two are intersecting each other. Then the angle between them, how to find angle between them? Then that is cos theta is equal to, there is a formula cos theta A1 A2 B1 B2 plus C1 C2, okay, by root over A1 square B1 square C1 square and root over A2 square B2 square plus C2 square. Okay, even from this formula also you can derive this condition. If theta is equal to 90, cos 90 is what? 0. So if you take cross multiplication, we are getting this condition A1 A2 plus B1 B2 plus C1 C2. Okay, children, right? Right. And parallel condition, one another, okay, see this is perpendicular. So parallel condition, one another condition for parallel lines. Parallel lines means there are A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This is one another condition for parallel. Okay, children, this is parallel condition. This is perpendicular condition. There are two conditions. Same direction ratios are in same proportion, parallel. Direction ratios are satisfying this condition, perpendicular. But neither parallel nor perpendicular, then this is acute angle or obtuse angle. Then there is a formula to find angle between them, A1 A2 plus B1 B2 plus C1 C2 by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. Do you understand, children? These are the basic concepts of this one. Okay, and centroid, that and all, you know that centroid of triangle. Okay, if 3 points are given, x1 plus x2 plus x3 by 3, or else that also you write. Centroid, sometimes we need centroid of triangle. Or before going to that midpoint of line joining two points. These are all 11th concepts. Midpoint of line joining two points. Midpoint of line joining two points, if P x1 y1 z1 and Q x2 y2 z2 are any 2 points, then Rx, okay, R is a midpoint of line joining. This is P, this is R, this is Q. R is equal to, point R is equal to x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. This is about midpoint of line joining 2 points. And then next, centroid of triangle formed by centroid of triangle. So this and all recapitulation. Already we studied in 11th standard. Okay, if A x1 y1 z1 and b x2 y2 z2 and c x3 y3 z3. Then centroid of triangle ABC, it is denoted by G. So x1 x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. Sum of x coordinates by 3, sum of y coordinates by 3, sum of z coordinates by 3. This is about centroid of triangle ABC, children. And section formula also. We have section formula, that is what? R divides P x1 y1 z1 and Q x2 y2 and z2 internally in the ratio. First thing is internally. So R is equal to mx2 plus nx1, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, and mz2 plus nz1 by m plus n. This is the point. Okay, section formula internally, divides internally. See, diagram is like this. See, this is P and this is Q, this is R, ratio M is there. Do you understand, sir? And external ratio, that also will write. Externally, R divides externally, then R is equal to, replace plus by minus. See, this is P, this is Q and this is R. Externally, if we extend the PQ, then we will get point R. Then the point R in the ratio mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n. This is the required point of which divides APQ in the ratio m is to n externally. These are all 11th standard concepts, children. Okay. Midpoint, centroid, internal ratio and external ratio, these are all we studied in 11th standard. Okay, this year you know that DRs, direction ratios. What is meant by direction ratios? Direction ratios of 3 points which are proportional to direction. Direction cosines. What is meant by direction cosines? A directed line, a vector which makes alpha, beta, gamma, directed angles with the positive x, y, z axis. Then the cosines of these angles, directed angles like cos alpha, cos beta, cos gamma are called direction cosines, also denoted by LMN. What is the relation among the direction cosines of a line? L square plus m square plus n square. Then what about the relation between direction ratios and direction cosines? If you know ABC, or direction ratios of given vector, then plus minus a by root of a square plus b square plus c square, comma plus minus b by root of square root of a square plus b square plus c square, and comma plus minus c by square root of a square plus b square plus c square. That already we saw that. Okay, using L by A is equal to m by v is equal to n by c is equal to lambda, will derive lambda value with the help of ABC. Okay, children, this much we discussed today. And now, okay, this is the introduction regarding three-dimensional geometry, right, children? Right? Three-dimensional geometry in 12th standard. Before first exercise, step by step we'll study, children. Okay, nothing to worry. Just we'll do this chapter alone little slow. This one and probability, another chapter, probability, little slow will go. We'll do in little slow manner. Why? Because some students they fed up with this chapter. They will omit this one. I don't know why, but I told some lack of things like imagination. They are unable to imagine the figure. That is one minus point from your side, and also and sometimes they are not regular to this one. Okay, some concepts are missing between okay in between chapter. Okay, they'll miss some concepts like they are not aware of direction questions, how to find, they don't know direction ratios, what is the relation between them, that and all they don't know. And then some lack of proper practice. Some students they won't practice. Okay, if they are not practiced properly, then also they feel difficulty. So in order to avoid all these things, you this particular chapter alone properly you practice, read all the concepts better, that very clearly given in NCERT book. You read NCERT synopsis, I mean before exercise what all concepts identities are given, each and every line if you read now you can understand better than this. Okay, okay children, thank you children.